Have you ever wondered what all those labels and functions on your stripper tools are? Most of us might just assume these are something we don't need, or perhaps we aren't using these features correctly. In this video, we'll cover in detail what every feature does, what you can use it for, and how to properly use it, as well as some limitations, important considerations, and tips on using strippers. Most of the technical information in this video comes directly from manufacturers, as well as military manuals. So whether you're new, just starting out, or an experienced professional, I'm sure there's some nugget of information for you in this video. Of course, a wire stripper can strip wire, but there are some important considerations when doing so. These round stripping cutters will often be labeled twice, once for stranded and once for solid. We can infer easily enough what these refer to. You strip solid wire with the gauges on the solid side and stranded with the stranded marked side. Stranded wire will have a more empty space in between the wires, requiring a larger cutting hole so as not to damage the strands. However, these are just suggestions. Solid wire thickness can vary due to manufacturers, and stranded wire will vary even more depending on the strand thickness and other factors. So use these markings as a starting point, not a set in stone rule. Before stripping a bunch of wire, you'll want to dial in your technique and ensure a proper cut based on the wire you're using. So to start, get a piece of wire to sample with. Place the wire in the proper sized hole and strip about 1/4 inch of insulation. When doing so, do not rock or torque the pliers. This can cause damage to the wire, but more importantly, will introduce unacceptable inconsistencies as you're stripping wire. Next, move down another 1/4 inch and again strip the insulation. This is important because it allows us to inspect the spot we previously cut and stripped. Now we could evaluate if we're good or we have to make any changes. Get up close and check for broken or nicked strands. A proper strip will not damage or nick any of the wires. Also, check the insulation to see if any strands stayed in it. If you have broken and nicked strands, then you have to adjust and move up to a larger size. However, if your insulation looks uneven, broken, and stretched, you have to move down to a smaller size. Repeat this test with the different sizes until you get a proper strip. Perfect cuts are the goal here, but generally wiring is over-engineered anywhere from 25% to 50%. So even in military applications, a 10% cross-sectional damage is acceptable. Regardless, making a habit of using damaged wire is not good. So always shoot for the best possible strip. These style of wire stripper tools will generally have pliers, but we also have some like these with no pliers, instead being more wire focused and just having cutters on the tip. Sheet metal pliers are pretty useful, but it's important to consider that they're not very stiff or strong. With a small amount of torsional force, the pliers will bend out of the way and jam. Regardless, these do come in very handy, and I'm often glad to have these pliers. We then have this stripping tool which has full-on pliers. These of course are a fully suitable replacement for pliers. They're large, strong, and are definitely not going to bend. Pliers like these are important when working with electrical in order to break off socket tabs and to get those knockouts out. Additionally, they're good at general plier stuff. And while you can get by with the sheet metal kind, these bigger ones are a real game changer. Another feature of these larger plier strippers is that they're also reamers. The outer edge of the plier tips are left square and jagged on purpose. This allows you to push the tip into conduit or metal cutouts and remove the sharp edges on these materials. This helps bevel that out a little bit so as not to damage wires as they rub against the sharp edge. Another common feature on sheet metal wire strippers is what seems to be a random hole near the edge. It's often not labeled, though in this case it is. This hole is for putting loops in wire. This is very common for outlets, light switches, motor controls, and many other electronic fixtures that use bolts to hold the wire. To use this, you strip around 1/2 inch of wire and use the hole to make a loop. You then place this wire on the bolt. When placing the wire, make sure to put it on the side that will pull the wire in as you tighten. If you put it on the other side, the wire will be pushed out as you tighten the bolt. Strippers will often have bolt cutters. These holes allow you to shear bolts and shorten them. This is useful when installing many sorts of electronic fixtures that will come with long bolts that aren't always necessary. This is a problem not only because it takes an unnecessarily long time to screw it in, but because these longer bolts can result in damaging or squishing wires, causing other issues. Some cutters, like these sheet metal cutters, will be threaded. The idea here is that you thread the bolt in and shear the bolt. Then, as you back it out, the thread on the tool acts as a die, reforming the threads if they sustained any deformation. However, there are plenty of quality options that do not have threads, and in my experience, the threads aren't really necessary. Pretty much all wire strippers will have cutters on them, and they're pretty straightforward with a couple of important considerations. Wire stripper cutters are not a suitable replacement for something like dikes or linesman pliers. Pliers like these have blunt, strong blades used for cutting hard materials and can handle that without sustaining too much damage. Wire cutters are much sharper and not as hard. If you're cutting steel wire or other hard materials with these, you'll soon find your cutters blunt, full of nicks, and unable to cut wires as well. Many cutters like these will even specify only cut copper, which is soft and won't damage the blades. The Knipex product information PDF also specifies that the cutter should be used with aluminum or copper. However, you can cut steel with these, and that is by using the bolt cutters. On a good quality pair, these cutters are good enough to even cut copper. And here you don't have to worry about blunting or damaging the blade. So you could use the bolt cutters to cut steel wire. It is important to consider, however, that threaded cutters like these could sustain damage to the threads if you're cutting a lot of wire. This, however, is not a concern on some like these that aren't threaded. In my experience, I prefer the ones that are not threaded. Not only because there's no concern of damaging the threads, but because I often encounter screws with the wrong pitch and other materials I like to cut that are not threaded. Wire crimpers are a standard on many stripping tools, and they come in very handy, making easy crimp connections with little fuss. Now, wire crimps get a bad rap for being unreliable. However, most of the time it's user error. I've made an entire video on properly crimping wires, which you can watch next. It is important to consider that for critical applications, as military, space, industrial, and other professional applications, a dedicated special crimper like this is required. But for personal, automotive, and repair work, these yield excellent results that can work very well. If you want to crimp 16 to 10 gauge wire, you'll place it in this divot to crimp it. 22 to 18 gauge will be placed on this divot to crimp. We also have another one that says insulation only. Crimping the terminal here will not put a divot in the material and is less likely to damage the insulation. However, a divot is a more secure option. We also have color codes, which are in reference to the color size code on our crimp connection insulation. Let's quickly go over making a proper crimp. Strip around 1/4 inch of wire. Place it in the barrel, protruding from the other side. Place the crimper on the barrel with the divot on the non-gap side. Push the tool slightly behind the front edge and press down hard. You should have a bell mouth at the front with a little bit of visible wire. Give the wire a solid, strong pull. If your size and crimp is correct, this will not come out. On these strippers, we also have a large crimper that indicates 7 to 8 millimeter auto. In this case, it's for spark plug wires. There's different methods for putting together spark plug wires, but in this case, we cut the wire exactly at the length we need. We place our rubber cover on the wire. We then insert this metal tab right below the graphite conductor about halfway. We then fold it back and place the wire in the connector. With the conductor at the bottom, we crimp it down with our wire crimper. There are, of course, more details and nuances to making a spark plug wire, but that's a topic for another video. You'll often also encounter other niche applications like coaxial crimpers and other crimpers like that. A common tool on the market now are automatic wire strippers, and these, for certain applications, are awesome. These pliers have cutters, so you can cut your wire to length. Then you place the wire in the jaws and just snap the insulation right off. These will have adjustment for how tight the blade bites down, and in my experience, they do a pretty good job. But these tools aren't without their drawbacks. An automatic wire stripper, you don't get all the bells and whistles from a regular crimper. You don't get the cutter, the pliers, the crimpers, the bolt shears, and all these other things. What this means is that generally you can't run with this tool alone, whereas something like these Irwin, you'll have all the capabilities built in and everything you need. Also, these strippers work only for smaller wires, with around 12 gauge being its max capabilities, depending on the hardness and thickness of the insulation. Regardless, a wire stripper like this for certain applications is a great tool. All tools shown in this video are linked down below.